For this set of notes, we're going to be adding and subtracting rational expressions. The essential question is, when you have unlike bases, what should you do in order to make solving the rational expression more simple? Steps to adding and subtracting rational expressions. For step 1, you're going to find the LCM, lowest common multiple, for the denominators. Number 2, you're going to multiply every term by the LCM and bust out that fraction. Number 3, you're going to simplify and factor if possible. So for our first example, we have 9x plus 12 divided by 16 minus 7x plus 2 divided by 16. So here we actually have the same denominator, so we actually don't have to worry about getting a lowest common multiple. So we actually get to just subtract this value from that first value. So just be careful that this negative here actually gets distributed to both those terms. So this is going to, so let's rewrite our 9x plus 12. Rewrite this as a single fraction with one denominator, and then that negative, or gets distributed to that positive 7x, so we now have a negative 7x, and the negative also gets distributed to that 2, so we have a negative 2. And we're writing it over one fraction. Okay? So now I'm going to combine like terms on my numerator. So I have a 9x minus 7x, which is 2x. So that gets rid of these. And then 12 minus 2 is a positive 10. We have this all over one denominator 16. We're going to go ahead and factor now, simplify our numerator. So 2 is our GCF plus 5. And then we're going to have divided by 16. So that means that these will actually simplify, and we just get an 8 on the denominator now. So our final solution is x plus 5 divided by 8. For our next example, we have y squared plus 8y divided by y squared minus 9 plus 2y plus 21 divided by y squared minus 9. Again, we have a common denominator already, so we get to just add our fractions. So I'm going to go ahead and combine this so that we have just one fraction. So I have y squared, there's no other y squares to combine, so I just get to rewrite that. 8y plus 2y is a positive 10y, and then 21 is just my other constant. This all goes over the same denominator of y squared minus 9. So now we're going to go through and see if we can factor any of this stuff. So I see that we can actually, whatever multiplies to 21 but adds to 10, I know 7 times 3 multiplies to 21, and 7 plus 3 is 10. So since I have a coefficient of a 1 right there, I just get to write this with the parentheses like this. So here I can do x plus 7, and then I also have an x plus 3. And then here we have a difference of 2 squares. I know that it's a perfect square because it's a 9, so 3 times 3. And that y squared is also a perfect square with y times y. So I have a y plus 3 and a y minus 3. So now I'm going to go ahead and simplify anything that I can cross out. Sorry, these should be y's and not x's. So now I have y plus 3 cancels out, and I'm left with my single rational expression of y plus 7 and y minus 3 as my denominator. For the next example, we actually see that we have two different denominators there. So this is where we had to figure out the lowest common multiple for this. So just work with the numbers first, 2 and 3. We know that both those numbers go into 6. That's the lowest common multiple that they go into. And then x, they both already have x. So we get to just rewrite that x. So 6x is my LCM. So that's the value I am going to multiply both fractions by. So multiply by 6m. Multiply by 6m, and now, I don't know where I'm getting m's, hang on. There should be x's. I'm saying LCM. Okay, so it should be x's here, x is there, and then now we want to see 2 goes into 6 3 times. X's divide out, so just 3 times 15, which is 45. And then 3 goes into 6 2 times, and those x's get to cancel out too, so just 2 times a negative 16. So 4 minus 16, which is negative 32. Okay, and then so when we have 45 minus 32, we get 13. And then our LCM gets rewritten on that denominator because we were able to subtract those fractions all because we had a common denominator of 6x. So we get 6x down there, and we can no longer simplify our fraction. Okay, so let's try that one again. So if we have a squared minus an 8a on the bottom, so we need to figure out, just looking numerically, so this is just an invisible 1. So we know that 8 has to be our lowest common multiple for our number value. This has an a, but this has two a's. So a squared actually has to be our lowest common multiple for our variables. So this is what we are going, this is our LCM. So this is what we are going to multiply both the numerator and the denominator will just be 8a squared. So we have 8a squared here. So we know that the a squareds will cancel out here. The 1 has to stay there, or the 1 is canceled out because of the 8. 8 divided by 1 is 8. So now we have to do 8 times 4, which is 32, and that a is still with that one. And then 8 and 8 cancel out here, and that a is just the value that we have to multiply here. So this is going to be minus 7a. And then don't forget to write your LCM on that denominator, because that's why we were able to subtract those fractions in the first place. So now we're going to go ahead and see if we can simplify anything. So I know that I have a GCF of an a here, and I get, oh sorry, we can just combine like terms. Let's do that first. So if I have 32a minus 7a, we are going to be left with 25a, and then we have 8a squared. Now we are actually able to cancel out our a's here, and then this one is just going to be an a left on the bottom. So now I'm left with my final rational expression, which is 25 over 8a. In our next example, again, we see things a little bit different. This time we actually have to factor a GCF thing out. So we want to see on that value, that 5k minus 10. So I have a GCF. So we're only working with the denominators here. So let's just rewrite this with a denominator there. So then we see that we have a k minus 2 and a k minus 2. So what is this equation missing? Well, it's missing that 5. So we know that we have 5k, let's erase this, so we know that we have 5k minus 2 as our LCM. So as you guys start getting better at this, you'll see that since this is rewritten as 5k minus 2, and that already is our LCM, this fraction is actually going to stay the same. So k squared plus 16, and then we have our 5k minus 2 down here. However, this fraction here is missing the 5, so we need to multiply that fraction, both the numerator and denominator, by 5. So negative 4 times 5 is a negative 20. And then now we have our 5k minus 2 down here. So like I said, as you guys start getting a little bit better at this, you guys will start kind of seeing that you are able to go through this process a little bit quicker. So sorry, this is going to be a positive because I already wrote down the negative there. So then now I'm going to go ahead and I have a common denominator now, LCM, so now I get to subtract our fractions, or subtract our numerators. So this is now k squared. I have a 16 minus 20, so that means I'm going to have a minus 4 here, and then I still have a 5k minus 2. You want to leave that factor because then it will actually help us when we go to factor this numerator now. So in our numerator, we now have a difference of squares, so I have a k plus 2 and a k minus 2. You're going to go ahead and divide that by our LCM, our denominator there, and we see that we get to cancel those out, so our final rational expression is k plus 2 divided by 5. For our last example, and for tonight's notes, we're going to do 7 divided by y plus 8, 35 divided by y squared plus 11y plus 24. Again, this one's already factored all the way. We need to factor this one. So what number multiplies to 24 but adds to 11y? So since I have a coefficient of 1, I just get to rewrite this as the parentheses. I'm going to go ahead and bring down that first rational expression. Since I don't get to factor it, this should be a plus sign. And then that 35 is not going to change. So this, I know that, so multiplies to 24, so I have a 3. times 8, and they're both going to be positive because I need a positive 11. And then now I see that this fraction has the y plus 8 and y plus 8, so this fraction is actually missing that y plus 3. So our LCM is y plus 3 and y plus 8. So I'm going to multiply this fraction by y plus 3, just so that this can actually get my lowest common denominator. So let's go ahead and rewrite this. Distribute this while we're doing that. So 7y plus the 7 times 3, which is 21. We now, and then it's going to be plus 35. So we now get to write this all over our LCM. Leave it in factored form again because you don't want to redistribute this and then have to factor it again to see if we can simplify. Go ahead and combine these like terms. 21 plus 35, we get a 7y plus 56, and then we get a y plus 3 divided by y plus 8. Now we're going to go ahead and take a GCF out of this value up top here, and then 7 goes into 56 8 times, and we're still left with our y plus 3 and our y plus 8. And luckily these get to cancel out, making our fraction even smaller, so now we are left with 7y plus 3. And that is our final rational expression. Again, you guys, if I go too fast, please pause it at any time so you guys can repeat it. If you don't understand it, rewatch it as many times as you need to.